Okay, this is the lecture for MAT 175, Lesson 1, and these cover sections A9 and also 2.1. And we will be working through functions. Okay, determine whether a relation is a function. We have what we call an ordered pairs. And as you can see here, instead of x and y coordinates, the x coordinate, that would be the state. The y coordinate, that would be the y, or the number of representatives. So as you can see, we have an ordered pair would be just basically nothing more than x and y values and no more. Whereas a function, let x and y be two non-empty sets, function where you have x has only got exactly one y. In other words, for each x there is only one y. So this x only has this y, this x value has only this y, and only one there. So if we were to look at this example here, for the x values, this would be the level of education. The y values, they would be the unemployment rate. You can see that for each x, there is only one y value. So we could say that this would be a function. And so we could say that the domain is always the x values. In this case would be the level of education. High school diploma, college, graduate, and so on. Whereas the range, those are the y values. And so those are the unemployment rates. Here we have a relation, but is it a function? Well, this x has only one y. The 0.74, that has only one y. The 0.73, that has 3067. But the 0.86, that has two y values, two prices. So we can say that this relation is not a function because for this x there is not only one y, there are two y's. So it is not a function. Not a function. Okay, determine whether the relation represents a function. So we would look at, in this case, the x values. Here's a 2. If there's another 2 here, it's not a function. So here we have 2, 3. The 2 has a 3. Here the 2 has a negative 1. So the the x value 2 does not have only one y value. It has 2. 2 has a 3 and 2 has a negative 1. So this would not be a function. So let's see here. We have negative 2. There's only one x value that has negative 2. There's only one x value that has a 4. One x value 4 has only one y. This negative 2 has only one y. 3. This x value 3 has only one y, which is negative 2. This 2 has only one y value, negative 1. So this would be a function. Well, let's see if the last one is a function. 4 has 3. But we also have a 4 and a negative 3, so this would be not a function. And all it takes is just one x value to have more than one y, and the whole set is not a function. Okay, this relation is a corresponding between two sets. If x and y and two elements of these sets exist between x and y, then we can say that x corresponds to y, or only that y depends on x. We write x, for each x there is only one y. So can we say that this line is a function? Well, if for each x there is only one y, then yes, it is a function. And we have this equation, y equals equals to 3x minus 1. So we can say that this relation is also a function. Determine whether a relation represents a function. Now, anytime you see a y squared, it is not a function. A y squared is not a function. So why is that? Well, if we were to solve for y, we could see that you're going to get 2x values. If we were to solve for y, apply minus 1 to both sides, and then apply the square root to both sides. Well, when you apply the square root, you have to have a plus or minus there. Well, not only are you going to have x positive, but you're going to have x as a negative. So there's 2 for each x's. There's actually 2 y values. Since the values for x are greater than 1, you would have 2 outputs for y. Okay, the sum and difference of product and quotient of functions. If you have f and g are functions, the sum f plus g, basically these are 2 equations added together, 2 functions, is defined by f plus g parentheses equals to f of x plus g of x. So basically, when you see it written as f plus g or f plus g parentheses x, I like to go ahead and write it out as f of x plus g of x, and then go ahead and combine the functions from there. The difference, f minus g, is a function is defined by f minus g of x is equal to f of x minus g of x. So we can say that this, it helps to write it in this format before we go ahead and simplify the algebraic expression. Product, f times g, we know product means what? Multiplication. And so f times g parentheses of x is equal to f of x times g of x. So what we're doing here is we're taking the 2 functions and we're multiplying them together. And so we get a product that way. Now quotient is f over g, is a function defined by f over g of x, or f of x over g of x, where g of x cannot equal 0 because we get an undefined relation there. Okay, so let's take a look at some examples. Here we have f of x is equal to 2x plus 3, g of x is equal to 4x cubed plus 1. So we have 2 functions here. And so we have f plus g of x, and so I would like to split that to f of x plus g of x, and we're going to substitute each one of these equations in there. So the f of x, that'll be the 2x plus 3. The g of x, that'll be the 4x cubed plus 1. And so we combine that all together, and really the highest exponent always goes first. And then so that'd be 4x cubed plus 2x squared, that's here, and then the 1 and the 3 get combined to be 4. Alright, now let's see what we can do with the f minus g. So here's the f of x and the g of x, and now we're going to subtract the 2. And so we have the 2x squared, that's our f of x, plus 3, minus, notice we have parentheses around the second term, because this minus has got to be distributed. So we end up with a minus 4x cubed minus 1. And so we get that minus 4x cubed, and then we get that positive 2x squared, but then you get the 3 minus 1, and that's 2. So that negative's got to get distributed, and so that becomes a minus 1, and so that's where we get the 3 minus 1 is 2. Okay, the f times g of x, that's f of x times g of x. So basically what we're doing is we're going to FOIL these two. And there we go. So we FOIL them. 2x squared times 4x cubed. 2 times 4 is 8. X squared times x cubed, that'll be x to the 5th. And then 2x squared times 1 is 2x squared. And then 3 times 4, that'll be 12x cubed. And 3 times 1 is 3. And so there we go. We have that 2 times 4 is 8. X squared times x cubed. We're adding the exponents, multiplying the x's. We're adding the exponents. And so that's why we get the x to the 5th. And then we have the 2x squared times 1, that's 2x squared. And then 3 times 4 is x cubed, so that'll give us 12x cubed plus 3. And normally we want to go ahead and put them from highest exponents to lowest, but they didn't do it in this case. Now here, f over g of x, here's the f of x, 2x squared plus 3, the g of x, that's the 4x cubed plus 1, and then that's it. That's all there is. So the division ones are actually the easiest ones to simplify because there's nothing really to combine between the two most of the times. Okay, and this is just a summary here. I'm not going to basically a function for each x, there's only one y. And so you can go ahead and read through that summary at your leisure whenever you get a chance. Okay, find the value of a function. Here's a function, f of x equals to negative 3x squared plus 2 of x, and we want to evaluate that. So basically we're taking the f of 3. Okay, so it's like we're cutting the x out for each x, put parentheses there. And then we're going to put the 3 in the place of the x. And so what are we going to do first? Are we going to apply the exponent first, or are we going to multiply first? Well, the order of operations tells you to apply the exponents first. So this would be 3 squared is 9. 9 times negative 3 is negative 27. Negative 27 plus 6 is a negative 21. Alright, let's now go ahead and try the b. F of x plus f of 3. Well, you already have f of 3 here. We know f of 3 is negative 21, so all we have to do is take the f of x, which is this, and apply minus 21 to it. Okay, so we had 3x squared plus 2x, and then we already figured out that the f of 3 was negative 21, so this would be negative 3x squared plus 2x minus 21. Okay, C. Here, what this means is you're going to multiply 3 times the whole function. So really what you're doing here is like you're putting parentheses around this function, and you're just distributing the 3 into everything. So for C, here's the 3, and so it's like you're going to multiply 3 times that whole function. So you're going to distribute that 3, and you get negative 9x squared plus 6x. Okay, for D, you've got f of negative x, and so now you're going to put negative x in wherever x was. So again, it's like you're cutting that x out, put parentheses there, cutting that x out, put parentheses there, and then you're going to substitute negative x in each one. Well, this would be like saying negative x times negative x is a positive x times negative 3, that's a negative 3x. And then negative x times 2 is a minus 2x. Alright, and so now for E, now here the negative is outside. Here the negative was inside. So you had to distribute the negative and the x. Here the negative is outside the function. So it's like you're distributing that negative. So that would be negative times negative is a positive 3x squared. Negative times 2x is a minus 2x. excuse me. Well, here, f of 3x, what do you think you're going to do with that? Pause the tape and think about that for a minute. And I'll give you a moment to think about that. Okay, well, let's see how you did. Again, it's like you're cutting the x out, put parentheses. Okay, and then you're going to substitute in that 3x. So anything that's outside of the function is going to get distributed basically into the whole term. Anything that's inside is going to get substituted in for the x. The thing that tends to confuse people is that you have to think that people see this x here and they think they want to make it x times x, but no. It's like you're cutting that x out and there's a hole there. There's nothing there, just parentheses. And then you're going to substitute that 3x in there. And so it's just 3x, and that's all, no more. Just 3x here too, no more. Parentheses, and then this is squared. And so this would be 3 squared. Again, order of operations, exponents is first. 3 squared is 9, x squared. So 9x squared times negative 3 is a negative 27x squared. And then 2 times 3x is 6x. Okay, now what do you think you're going to do for this? Alright, and pause the tape and try this one. G. Go ahead and pause it and try the tape. Okay, now what you're going to do is you're going to cut that x out, put parentheses. Cut that x out, put parentheses. And what do you think is going to go in the parentheses? The x plus 3. Okay? Well, what do you think you're going to do here? Can't do x squared plus 3 squared. Can't do that because we don't know what x is. So what you have to do is put negative 3 times x plus 3 times x plus 3. It's like you're taking that x plus 3 parentheses, putting in a copier and hitting 2 copies. So then you distribute that. Then what you do is you FOIL that x plus 3. X plus 3 times x plus 3. Well, x times plus 3 and x times x is x squared. X times 3 is 3x, and 3x is 6x. And then 3 times 3 is 9, and then what you can do is distribute the negative 3 that way. Now there's another way in class I can show you that I think is a better way to do it, but this is the way this slide did it, so we'll stick with that for right now. Here you have to distribute the 2, and so that would be 2x plus 6. Okay, so here we're going to distribute the negative 3, negative 3x squared, and there's no other x squared, so it's negative 3x squared. 6 times 3 is negative 18, negative 18x, and plus 2x is a negative 6x, and negative 3 times 9 is negative 27, plus 6 is a negative 21. Okay, now we've got one more here. F of x plus h minus f of x. Well, this f of x is the same thing as this f of x. But the problem is, see this minus sign here? You're going to have to put parentheses here. Here you're going to have to substitute in x plus h. Okay, so here's your f of x plus h. So it's like you're going to cut that x out, put x plus h in there, parentheses squared. 2, where the x was, put parentheses, and then you're going to substitute x plus h in there. Minus. But because it's minus, you have to distribute that negative, so you have to have parentheses. And where this f of x was, you're going to put the negative 3x squared plus 2, but because it's negative, you got to distribute it. That's why we have parentheses here. Okay, so what do you think we're going to do here? Is it going to be x squared plus h squared? No. We're going to put x plus h times x plus h, FOIL it. x squared, and then xh plus xh is 2xh, and then h times h is x squared. Here we're going to distribute that negative, and that's going to give us negative plus 3x squared minus 2x, and here we distribute the 2x. So this is 2x plus 2h minus times a minus is a plus 3x squared, minus times a plus 2x is a minus 2x. Here we're going to distribute the negative 3. So that would be negative 3x squared, and negative 3 times 2 would be a minus 6xh. Negative 3 times plus x is negative 3h squared. So here's your negative 3x squared. Negative 3 times 2, that's going to be your negative 6xh. Negative 3 times h squared, that's going to be negative 3h squared. And here you got a positive 2x and negative 2x, so those two go to 0. They cancel out, go to 0. And so you've got your plus 2h is here, plus 2h, and your plus 3x squared is here. Okay, well, you have your minus 3x squared and your plus 3x squared, they cancel out. You've got a minus 6hh minus 3h squared plus 2h. Well, at this point, you can split it. Okay, what they did is they factored the h out of the 6xh, the 3h squared, and the 2h, and then the h's can cancel at this point. And you get negative 6x minus 3h plus 2. Now, we're going to do more of these in class, but it's good to go ahead and go through these. I think the way you'll see the way it's demonstrated in class may be a little bit more comprehensive, more clear to you when we go through it in class. So don't worry if you don't get this. But it's real important that you learn these, because you're going to see these in calculus. So you have to absolutely be able to do these. Okay, and here's a summary. Alright, and so you want to go ahead and read that summary. Alright. Find the domain of a function defined by an equation. Okay, we're going to go over interval notation. Alright, interval notation of solutions inside the boundaries. Here we have greater than or less than. Use parentheses. So here we have x is greater than a but less than b. So that means that x is greater than a but not including a. So it's parentheses there. And is less than b but does not include b. So that's parentheses. So x is all values in between a and b. And so this is known as interval notation. Now here we have greater than or equal to or less than or equal to. We used closed brackets. So here if we were to say x is greater than or equal to a but less than or equal to b, then here's a bracket, close bracket on a, x is greater than a, close bracket on b, because the equal sign, that's what will give you the clue that you need the close bracket. X is less than b, so there's a close bracket on b, and x is less than that, so it's going to be in between, all values in between a and b, including a and b. Whereas with these, it was greater than or less than, does not include a, does not include b. There is no equal to there, so these are open parentheses. Here's half, open, half closed. Here x is greater than or equal to a, so that a gets a closed bracket. But x is less than b, there is no equal to sign there. So that gets an open parentheses. And so x is in between a and b. And here's the interval notation for that. Bracket for a, comma, b. b. So as you can see, there's a consistency here between the line graph and how it's written in interval notation. Interval notation, interval notation. Okay, now here, x is greater than a or less than a, rather, x is less than a or greater than b. So, and notice, no equal to sign there. So it's open. That's going to be your clue whether it's open or closed. No parent, no equal to sign, it's open. So it does not include a, but it is all values less than a. Or x is greater than b, so it's going to be again open at b, and it's going to go to the right. Now anything that continues on and on forever, this arrow, is going to be negative infinity. Anything that's going to the right, that's going to be all x values tend towards positive infinity. Infinity or negative infinity are always open. Infinity and negative infinity are always open. Always. So this is an open parentheses, negative infinity, comma, to a. Since a is open parentheses, does not include a. Or open parentheses at b, again here's infinity, open. Infinity is always open. Now we're not using a union sign here. In this case we're just using or. Now here x is less than or equal to a or greater than or equal to b. So it helps to do the line graph first. Here's a, it's going to be less than a, so it's all values less than a. Well here it's continuing on, tends towards negative infinity. Close bracket at a, tends towards negative infinity. The lowest value always is to the left. So negative infinity has got to go before a. If somebody were to write it a comma negative infinity, that would be incorrect. And that's a common error that students make. So this is going to be open, negative infinity, comma, a, close bracket, or b, comma, to infinity. Okay, here's x is greater than or equal to b. Here's b, close bracket, goes towards infinity. So this is going to be close bracket at b to infinity. Alright. And there's the finding domain of the function relation. Start with a domain instead of all real numbers. The domain are always the x values. Domain is always the x values. If the equation has a denominator, exclude any numbers that are given in the denominator. If the equation has a radical or even index, exclude any numbers that cause the expression inside the radical to be negative. So the way you want to look at this is you're going to have all real numbers. You're going to have a line with arrows going in both directions. And the only thing that's going to cause a break in that line is if you have an x in the denominator, or as if you have an x inside the radical sign. Alright, well let's see how that works. And those are the only two. That's it. Anything else is going to be negative infinity to infinity, or all real numbers. Alright, well let's see how that looks. Domain restrictions. When x is the denominator, you set the denominator equal to 0 and then solve. So 0 in the denominator is undefined. Cannot have a 0 in the denominator. That gives us an undefined value. So therefore, whatever that value is, you solve for that, and x that cannot be that value. And so we'll go through some examples of that. When x is a radicand, or inside the radical expression, radical sign, you set the radicand to greater than or equal to 0 and solve. You cannot have a negative radicand. So you set the radicand to greater than or equal to that number. let's look at some examples here. Now the numerator. Do we have an x in the denominator here? No, the x is down here. Is there a square root here? No. So the numerator, that would be like all real numbers. So we don't have to worry about that one. But the denominator, that has x's in the denominator. So what we have to do is we have to factor that denominator. We have to solve for that denominator. So we factor it. So we look at x squared, right? That's going to be an x and x. You got a minus sign and a minus sign, so you're going to have the c term is a minus, so the signs have to be opposite. If the c term was a plus, then the signs would be the same. C term is a minus, so the signs are opposite, and then you need factors of 3. Well, what are factors of 3? Well, just 3 times 1 is 3, and those are the only factors of 3. But you need to factor it so that you get that middle term as a negative. So you have to have a negative 3, x minus 3, and x plus 3 here. Because if you were to FOIL it, you have to get what you started with. So you always want to check when you factor, you always want to check your factoring. So it would be x times x is x squared, x times 1, that would be 1x, and a minus 3x. So 1x and a minus 3x, that would give you a minus 2x. And then that would be negative 3 times 1 is minus 3. So if you were to FOIL this, you should get what you started with. Now we set each factor equal to 0. And we can see that x equals 3 and x equals to negative 1. So whatever they equal to, they cannot have those numbers in the denominator. So in that case, this is set notation. This is known as set notation, but we're going to have to convert this to interval notation, and we will do that in class. Okay. Alright, here, do we have an x in the denominator, or do we have x inside the radical? We do not. So therefore, this has to be all real numbers. Negative infinity to infinity. Okay, there is no break in the domain. Here we have a radical. We have x as a part of the radicand. Well, what do you think we've got to do there? Okay, we've got to set the radicand to greater than or equal to 0 and then solve. And so when we do that, we're going to apply minus 3 divided by negative 2, and we get x is less than or equal to 3 halves. So this is set notation. The set of all x is such that x is less than or equal to 3 halves. Well, if you were to graph that, the arrow would go, it would be a bracket at 3 halves, and the arrow would go to the left. So this would be parentheses negative infinity, comma out of 3 halves, because it's less than or equal to is a closed bracket. And we will go through more of these in class. Alright, and that is the PowerPoint lesson for lesson 1. And we will, don't worry if you don't get these, we will go through these in class, and we will answer questions in class. Alright, well, have a nice day.